Right now, there are 8 billion humans on Earth, but 900,000 years ago, our entire species was reduced to somewhere between 1,000 and 10,000 individuals. We came closer to extinction than you can possibly imagine, and nobody knew this happened until scientists cracked the genetic code in 2023. What I'm about to tell you will change how you think about human history forever. Picture this. You're looking at the world nearly 1 million years ago. No cities, no technology, no agriculture, just small groups of early humans struggling to survive. And then something catastrophic happens that wipes out 99% of our ancestors. This isn't science fiction. This is the hidden chapter of human evolution that was buried in our DNA for nearly 1 million years. In 2023, a team of scientists led by Wang Jiehu at the Chinese Academy of Sciences made a discovery that sent shockwaves through the scientific community. They were analysing DNA from thousands of modern humans, tracking genetic mutations backward through time like a molecular clock. Then they saw something that shouldn't have been possible. Around 900,000 years ago, the genetic signatures collapsed. It was like watching a movie where suddenly 99% of the characters disappear from the screen. The data was screaming that something catastrophic had happened, but the numbers were so extreme that the researchers didn't believe them at first. For years they double-checked, triple-checked, and ran the analysis again with different methods. Every single time, the same result. Our ancestors had been reduced to a critically small population that lasted for over 100,000 years. Here's what makes this discovery so mind-blowing. When populations drop below a certain threshold, they usually don't recover. Biologists call this the extinction vortex. With only a few thousand individuals scattered across an entire continent, genetic problems pile up, inbreeding becomes unavoidable, and random disasters can wipe out entire groups. Most species that hit these numbers simply vanish forever, but somehow our ancestors didn't vanish. For over 100,000 years, longer than modern humans have existed as a species, they held on through ice ages, droughts, and the extinction of countless other species. Think about that. Your ancestors survived conditions that killed almost everything else on the planet. What caused this near-extinction event? The timing gives us a crucial clue. 900,000 years ago, Earth's climate system went completely insane. Before this period, ice ages followed relatively predictable 41,000-year cycles. But around this time, everything changed to brutal 100,000-year patterns. Glaciers became massive, covering huge chunks of northern continents. Sea levels dropped by hundreds of feet. And in Africa, where our ancestors lived, the climate became incredibly harsh and dry. Forests transformed into savannas. Savannas became deserts, and water sources disappeared. Imagine being an early human watching your world slowly die around you. Over generations, the animals you hunted went extinct. The plants you gathered became scarce, water sources dried up, and it wasn't getting better, it was getting worse for thousands of years. This created what scientists call a perfect storm for mass extinction, and that's exactly what happened to most human populations. Only a tiny group somewhere in Africa managed to survive. The evidence for this bottleneck is written in our DNA like forensic evidence from a crime scene. Every person alive today carries the molecular signature of those desperate millennia. Population geneticists can see it in our genetic patterns, the mathematical fingerprint of near extinction. But here's where it gets even more incredible. During this bottleneck period, something unprecedented happened. 2 of our ancestral chromosomes fused together. This is why humans have 46 chromosomes, while chimpanzees and gorillas have 48. This chromosomal fusion is incredibly rare. It happens maybe once in millions of years. But when populations are very small, unusual genetic changes can spread through the entire group much faster than normal. Today, every single human on Earth carries this fused chromosome. All 8 billion of us are walking evidence of those desperate times. What was daily life like during humanity's darkest hour, with only a few thousand individuals scattered across Africa? Survival meant mastering skills that most species never develop. Water came first, always. Your ancestors probably developed an almost supernatural ability to find underground water sources, to predict which seasonal streams would flow longest, to dig simple wells that could sustain a family through dry seasons. Food required incredible ingenuity. With most large game extinct, they became dietary generalists, eating insects, roots, tubers, anything with nutritional value. They learned which plants were toxic unless prepared properly, which ones could be stored for lean times. Fire became absolutely crucial, not just for cooking, but for extending the day, processing poisonous plants to make them edible, and maintaining the social bonds that kept these tiny groups together. Because social cooperation wasn't just helpful during the bottleneck, it was the only way anyone survived. Around 800,000 years ago, something remarkable happened. Archaeological evidence shows a sudden increase in fire use and more sophisticated stone tools. The population began to grow again, not slowly, but rapidly. Within a few thousand years, descendants of the bottleneck survivors had spread across Africa and beyond. They carried with them all the survival skills learned during the crisis, plus genetic and cultural adaptations that had been refined under the most intense selection pressure imaginable. The timing is too perfect to be coincidental. The genetic evidence suggests that the last common ancestor of modern humans, Neanderthals and Denisovans, lived right around when the bottleneck ended, as if the near-extinction event didn't just test our ancestors' survival skills, it forged them into something new. Here's where the story splits into three incredible journeys. The bottleneck survivors didn't just expand as one group, they divided into three separate populations that would become the most successful human species in history. One group stayed in Africa, continuing to adapt to changing environments. These would eventually become modern humans, us. A second group moved north into Europe and Western Asia, where they adapted to Ice Age conditions and became Neanderthals. The third group went east across Asia, becoming the mysterious Denisovans. All three carried the genetic signature of the bottleneck. All three had been shaped by those desperate millennia, but each developed their own specialized survival strategies for radically different environments. So why did our lineage ultimately dominate, while Neanderthals and Denisovans eventually disappeared as distinct populations? The answer brings us back to the bottleneck's lasting impact. While all three species were shaped by those desperate millennia, the African population our ancestors faced an additional challenge. Africa remained climatically unstable even after the worst crisis ended. This ongoing pressure kept modern humans evolutionarily flexible in ways that extreme specialization did not. When the three species finally met, Neanderthals and Denisovans were like finely tuned racing cars, incredibly efficient under specific conditions but hard to modify. Modern humans were more like all-terrain vehicles, not perfectly optimized for any single environment, but capable of handling whatever came next. This discovery completely changes how we think about human diversity and unity. Right now, some people believe that racial differences represent meaningful biological distinctions between types of humans. The bottleneck obliterates this thinking entirely. Everyone on Earth, meaning the everyone, descends from the same small group of survivors. We've only been separated for tens of thousands of years, which is nothing in evolutionary terms. The genetic differences between any two human populations are smaller than what you'd find within a single population of chimpanzees. We are all recent cousins, all products of the same evolutionary crucible,